Welcome back. In our previous demo, we took a look at writing asynchronous code that's useful for almost any kind of coding you would do in the .NET framework. By that I mean whether you're writing web application code, console application code, for components, for UI, etc. Those use cases where you use asynchrony for long-running network operations, long-running I/O operations, it's all great. But for this demo, we're going to focus in a little bit on a special case, and that's desktop application technology and things like Windows Forms, Windows Presentation Foundation, Xamarin Forms, just the kind of applications that can run on devices. They are special cases because they put some primacy on the UI thread. The user interface runs a lot of the code, which can lead to some side effects such as UI locking up and users unable to use your application. So why don't we take a look at some code I've got. This is a technology called UWP, Universal Windows Platform. It's a desktop technology or a UI technology, as the case may be, and it will show us some of the things that can go wrong when you have long-running operations that you run synchronously. We'll start out with this button here. Well, let's just take a quick look at the user interface we have. We've just got this counter that counts down to show that there's activity within the UI. We've got these rollover buttons. We've got kind of a status text box that we will utilize when we click this button, for instance. So watch what happens. Click this, the button's frozen, the number's frozen, I can't roll over anything. Essentially, we had our UI completely locked up, the kind of thing that end users definitely don't like. They think your application is broken, when in fact it's doing things in the background. Let's look at the effect that thread sleep has. This has the possibility, if you think about it, of doing the same kind of thing where you would lock up the UI because we're asking the code for a pause. But we click it says it's starting sleep, the counter goes fine, rollovers are fine, it's done sleeping. This one really seems to be playing well with the UI. How about this one, the async action? In this case, it's going to do essentially the same thing as the Hog UI, but it's going to go about it in a different way. So you can see the numbers are updating down here. The numbers are stuttering a little bit, but they're updating just fine. So in that case, we can see that this button definitely plays a lot better, a lot more nicely than the Hog UI. Let's drill in and take a look at what's going on. Our Hog UI is nothing too secret there. It's just basically counting from 0 to 29,999. But because it's putting all of its resources towards this loop, there's no opportunity to do anything else. There's no opportunity to update this text box with our number. It waits until the very end. It can't do the counter that it was doing. Can't do the rollovers. So this is really the danger of synchronous code in UI technologies. See what's happening with thread sleep. When we click that one, we used async, and you can see we used this one task delay, which, that's exactly what it did. It gave us 5 seconds between the starting sleep and done sleeping, but there was no effect on the UI thread because of this async and await keyword that we've worked with before. Finally, let's take a look at our async action. In this case, same thing, 0 to 29,999. We do a little bit more trickery. Again, I don't want to get too deep into the technology that's going on here, the core dispatcher and etc. Basically what it's telling us is that it is sharing that UI thread with the other processes that are going on. I'll fire it up one more time so we can have one more look at it and wrap up the demo with that. But I do want to emphasize that don't get hung up on this technology. Just know that if you take away one thing, that when you do use desktop applications and you're going to have anything that may run long, look first to async and await technologies. That's it, and I'll see you in the next demo.